Hello guys, good morning. My name is Mukesh Singh and welcome you to the CISSP domain 2, that is asset security, protecting security at assets. So after domain 1 we will be starting with the asset security. Let's start here. The first thing is classifying and labeling the assets. It's very important. You need to classify your assets and label them. Classification can be done on the basis of the importance or the purpose or the use of it, or how sensitive your devices or data is on behalf of that. So the first is defining the sensitive data. Number 2 is personally identify information, protected health information, proprietary data, organizational data, labeling, marking the data on the basis of data classification. So what watermarking of data, states of data, like data is in rest, data is in process or motion. We will be talking this in the coming slides. Data who is in the hard drive stored, that is called data in the rest, or process or motion, the data flowing through the networking cable, that called. So upcoming slide we will be talking about storing the data, document, media, optical media, chip, USB, what kind of a storage technology we will be using, protection of data, there is a TPM chip, keep the copy of cryptographic key, HSM when information is rest, and destroying the data. So how to destroy it? So better to smash. Let's talk about it. Smash with the hammer. You can see here, what's happening. So first thing is how to destroy the sensitive data. The one thing is called erasing, simply deleting the data is we can do that. But we do not suggest if the data is classified or sensitive to simply delete and that is it, because it is easy to recover it back. So what need to be done next is a clearing. Clearing means cannot be recovered by traditional tools. So if you are clearing it, it will be hard for recover it with traditional tool, but still not impossible. Purging, erasing the data multiple time, erasing it, formatting your drive again and again, that can be done also. Destroying it. Declassification is process of purging the media, so that is also possible. Sanitization, combination of any process that removes the data. Degaussing is magnetic, because the hard drive uses a magnetic rays to store the data on the platter. So magnetizing may help to delete or erase the data. That is a good way also, but the best and the final good way is called destruction, final state and most secure state. So if you have a old hard drive, or if you have a company's drive, the data you already taken, or you do not want it, you want it to be destroyed, it's sensitive, I think that's the way here, use this way. Okay. So next thing is guys here, MTBF. MTBF stands for mean time between failure, how long the device will run without failure. So if your device is running 8 hour, 9 hour, 10 hours without a failure, and then it is giving you 1 error or 2 error or 4 error, how to calculate it? Actually, let's understand it. For example, a system should operate correctly for 9 hours during this period. Okay, 4 failure occurred, adding to all failure we have 60 minutes, 1 hour. Calculating the MTBF. MTBF is mean time between failure. We would have mean time failure is 9 minus 1, 9 hours of the period, 4 failure occurred, that we can say 1 divided by 4 equal to 2 hours. So exactly after 2 hours the failure is coming. So that is how we can calculate it. Okay, after 5 days you see there is a 10 hours, after 10 days there is a 20 hours, after 20 days there is a 10 hour failure. So time taken for rectification is 20 days. So let's zoom it out here. MTBF, total operating days divided by breakdown occurrence. So 70 days, okay, total divided by 5 times it happens, 1, 2, 3, 4, 5 equal to 14 days. So MTTR is total repair time divided by breakdown occurrence. So breakdown occurrence is 5 and repair time by breakdown occurrence. So, 80 hours divided by 5 equal to 16 hour is the MTTR. So, that is how you can calculate MTBF. So, here we already know how to calculate this mean time to repair. Let us take another example. A system should operate correctly for 9 hours during this period. 4 failure occurred. Adding to all failure, we have 60 minutes, 1 hour. Okay. Calculating the MTBF, we would say total hour of downtime caused by the system failure and number of failure. So, here you can say the 60 minute divided by 4 equal to 15 minute, that just now we have discussed right now in the previous slide here. So, next thing is guys encryption algorithm. There are basically two types of encryptions are there. The one is called symmetric encryption, another one is called as asymmetric encryption. Symmetric encryption is one where the sender and receiver are using a same key to encrypt and decrypt the data. They are sharing a one key, both of them, that is called symmetric encryption. They along with the data he will send the key to the PC, but that is a secure way, like Diffie-Hellman and many other processes are there to transfer key securely. But the other is like asymmetric. Asymmetric mean computer 1 do have his own personal key and computer 2 do have his own key. So, he will lock with his key and he will unlock with his own key, that is much better even. So, that is called asymmetric. So, understand what exactly the difference is. Symmetric is also called secret key algorithm and asymmetric is also called public key algorithm. So, use the same key to encryption and decryption. Okay, I just talk about it, and use a different key for encryption and different key for decryption. Decryption is easily derived from the encryption key. Decryption key cannot be derived from the encryption key. Reversible process won't be easy with the asymmetric actually. Methods are inexpensive. The first one is very easy to do it because no longer few bunch of commands on the devices and you can encrypt the symmetric encryption, but asymmetric you need to add some extra servers for that. So, that may be little expensive. It is a digital signature kind of things. Next is it can be divided into cipher and block cipher. We will talking more in the next coming slide. Advantage is scalability. Okay. Faster in process because it is very fast to encrypt and decrypt because the same key, but usual this is take long time. Algorithm, there are basic algorithm are there. AES, advanced encryption standard, decryption standard, DES is there, there is a triple DES is there, RC4 is there and many more. Here as RSA is there, ECC is there, EL Gamal is there and Diffie-Hellman are the another type of encryptions there. So, let us talk in this one symmetric encryption algorithm. So, for example, advanced encryption standard, this is the latest one, AES. Okay. It came after the DES, successor of data. It used to be old days, but now we use advanced encryption standard. It has excellent key setup time, low memory requirements, its operations are easy to define against power and timing attack, provides strong encryption as DES. DES is the old, so it provide better security and encryption. Use 3 key size, you can use 128 bit encryption, 192 and 256 encryption key. Complexity of the cipher algorithm is increased, so that make crackers or hacker too tough to decode it. And what is DES? DES encrypt and decrypt data in 64 block using 56 bit key. So, that is why DES is no longer, we do not prefer it to use, we do use advanced encryption standards. So, understand here how does encryption work. There is a user Bob, he is writing hello Alice and the data is going to encrypt and hello Alice will become something else. And the user who is receiving, Alice is the one who is receiving it. So, when he receive, he is having a key, same key the Bob used to encrypt, same key he does get, receive that, he decrypt it with this one. but the key exchange take place between 1 to 2 is in a secure way. So, it is not able to hack, key also travel in the network, one computer to another, but they use some secure channel to communicate. So, that is symmetric encryption. Asymmetric encryption, guys, is a very good example here. Understand it. This is a plain text, somebody writing something, hello, how are you. Encryption, it is done with the public key, okay, is having his own key, the user one is having his own key, encrypted. After encryption, it becomes ciphertext, something codes. When it reaches to the destination do have his own digital certificate or a secret key. He receive the ciphertext, and then his key will be going to decrypt it, and he can read the plain text back. So, that is a asymmetric key encryption. So, guys, next is the last one is here, the scooping and tailoring. Scooping is a baseline of security control or used to determine which standard will be used for the organization. Tailoring modify those security control within the baseline. So, by looking to the need of your organization, you can decide it. It is not that this one is better over that, it is what your requirement is. Are you a bank or a IT organization or a finance organizations or a sales and marketing company? By looking to that, you can decide for it. So, guys, this is the domain 2. Thank you very much. Next session we will be working with the domain 3, and that is security engineering.